All right, let's jump right into this explainer. If you're out there making decisions about enterprise IT architecture, you already know that blockchain holds immense promise. But let's be honest, security concerns, they usually hold us back. Well, today we're going to flip the script. We are exploring how to reframe blockchain security from this daunting, scary barrier into a powerful engine for widespread adoption. We'll be unpacking a really comprehensive framework designed by the CGI Netherlands team and the Dutch Blockchain Coalition that honestly just changes the game entirely. So here is our roadmap for today. We're going to cover 1, the digital vulnerability problem, 2, the blockchain trilemma, 3, building the obsidian shield, 4, navigating privacy and compliance, 5, bridges of human trust, and finally, 6, the engine of adoption. Let's get to it. Starting with Section 1, the digital vulnerability problem. Let's navigate this chaos. Now, you really have to ask yourself, are our digital networks built on unshakable trust or hidden vulnerability? We're seeing this massive, rapid digital growth, right? But unfortunately, it's created incredibly fragmented data flows and, frankly, systemic mistrust among enterprise leaders. We're building these amazing, futuristic systems, but if the foundation isn't perfectly secure, the whole structure is at risk. It's essentially a massive tug-of-war. On one hand, you have the incredible speed of innovation. We all want speed, scale, and cutting-edge tech. But on the other hand, we are constantly battling chaotic vulnerabilities like data breaches and malicious actors. To actually adopt blockchain safely and effectively, we absolutely have to bridge this gap. Moving on to Section 2, the blockchain trilemma, balancing the core. Before we can solve anything, we need to understand the fundamental tension at the heart of blockchain itself. It's called the blockchain trilemma. Basically, it's like a giant puzzle where increasing any two of these attributes, decentralization, scalability, or security, usually decreases the third. So if you want a highly scalable and highly decentralized network, your attack surface might actually widen. Conversely, if you prioritize absolute security and decentralization, you're probably going to sacrifice transaction speed. Understanding these calculated trade-offs is step 1 in architecting any secure application. Which brings us to Section 3, building the obsidian shield, the 4 pillars of security. So the white paper identifies 18 specific security risks, and what they did is brilliantly group them into these 4 overarching pillars. Think of it as assembling a solid, impenetrable geometric shield for our network nodes. You see, you can't just audit the smart contract code and call it a day. You have to look at the network it runs on, the operational security of your actual human team, and the management policies governing the whole shebang. It's a top-to-bottom approach to resilience. Now, applying this framework creates a really stark contrast between public, permissionless chains and private, permissioned chains. A public chain, like Ethereum, relies heavily on community consensus. It's open to everyone, but that makes strict privacy incredibly difficult. On the flip side, a private chain, like Hyperledger Fabric, is controlled by a defined central party or consortium. This gives you known identities and much higher scalability. Let's put that into perspective with a concrete example. Think about a 51% attack. In a public chain, if bad actors monopolize more than half the hashing power, they can literally reverse transactions. And you, as an organization, have very low influence to stop it. But in a private permission setup, you control the nodes. That means your influence over mitigating those targeted attacks and managing things like forks is incredibly high. For serious enterprise adoption, that level of control is pretty much non-negotiable. All right, Section 4, navigating privacy and compliance, the GDPR challenge. Okay, so a secure framework also has to deal with strict legal realities. And there is a massive architectural clash right here. Under GDPR, citizens have the right to be forgotten. They can legally request you delete their personal data. But the whole point of a blockchain is immutability. Once data is written, it's essentially undeletable. So how do we fix that? The white paper's practical recommendation is crystal clear. Keep sensitive personal data completely off-chain. You might be thinking, hey, I'll just put a cryptographic hash of the data on the blockchain. That's anonymous, right? Actually, no. The Dutch Data Protection Authority has explicitly stated that a hash is still considered personal data because it can potentially be linked back to a person. So the absolute safest compliance route? Encrypt the data, store it off-chain, and when a user asks to be forgotten, you delete the original database entry and literally just throw away the key. Let's look at how this works in practice. Section 5, bridges of human trust, real-world applications. This brings us to what we call the Amber Bridge concept.
It's the idea that when those 4 pillars of security are handled properly in the background, the end user doesn't feel any of the complexity. Professionals can confidently execute complex, cross-border tasks without a second thought. The heavy lifting is invisible. They just experience speed, transparency, and most importantly, unshakable trust.
And these aren't just theories. Take a look at these specific permissioned blockchain use cases from the Netherlands. We have Mijn Zorglog, which secures maternity care data sharing between mothers, providers, and insurers. There's Luke, generating immutable digital fingerprints for building dossiers. And Consentus, allowing patients to manage their own medical data permissions across different healthcare systems. It proves that with the right framework, organizations can safely innovate today. Zooming in on those healthcare examples, Consensus and Mijn Zorglog, we can see exactly how they pull this off. They use hashed pointers and encrypted off-chain storage to completely protect sensitive patient data. By leveraging proven hospital authentication systems and keeping those heavy medical files safely off-chain, the blockchain just acts as an unbreakable, decentralized permission slip. It's a perfect balancing act between the blockchain trilemma and strict privacy laws. And that leads us to our final section, Section 6, the engine of adoption. The big takeaway here is absolutely clear. A multi-layered security framework is what creates the unshakable trust necessary for real digital innovation. When you approach your smart contracts, your network nodes, and your operational policies with these rigorous security measures, blockchain ceases to be a liability. It genuinely becomes your greatest asset. The framework is there, the real-world proof exists, and the path forward is laid out. So with this Obsidian shield in place, what bridges of trust will your organization build next? The next step in secure digital transformation is entirely up to you. Thanks so much for joining me for this explainer. Now go out there and keep building with trust.